Okay, hello students. So today we're going to discuss about three-phase system of soil. Okay,
Sir,
can you see here? I think title is give. I think you can see soil as three-phase system. Okay, so in nature we have already discussed in the previous class that soil uh, is considered as a complex material. Okay, so in the last class also we have discussed about the basic component of soil. In nature, soil present in a complex material and consists of mainly three components. Okay, so what are the main three components of soil? They are soil solid, water, and air. Okay, so here statement is given here: a soil mass is a three-phase system consisting yeah, consisting of solid particles, which is also known as soil solid or soil grains, and water and air. Okay. And next slide is what is given here. Soils can be partially saturated with both air and water present, or be fully saturated with no air content, or be perfectly dry with no water. So let's discuss about these two sentences. Okay, we can give more clarity. We'll have more clarity about these two statements from this diagram. Okay, now have an attention in this diagram. Now, in the first diagram, you can see here. Can you see this diagram clearly? Okay, I'll do one full screen. Wait. Okay, I'm just doing the full screen. Can you see this? I think you can see, right? Okay, wait. Yeah. So, in the first diagram, what you can see, some irregular shape, isn't it? Like a, it look like some boundary, isn't it? The irregular shapes, some are, all individual, this boundary are different shape, having different shape. Okay, so these blocks, irregular blocks are what? It is represented soil solid or soil particle. Okay, or you can say soil grain. Okay, so you can see in nature we'll get all soil particle have different shape and size. Okay, so sometimes you will get small sizes or very large sizes. So here this is a natural state of soil. So it is a particular, for a particular volume of soil, it is a, you can say microscopic view of soil mass. So all these soil mass contain this amount of soil particle having different shape and size. Fine. And among these soil particles, you can see some gaps also may generate it. I'll show you more clearly. Wait. Here, like this one. Hold on. So this one is a gap, isn't it? This one is a gap. Uh, Here also this one is a gap. This one here also. So many gaps are there. Small, large, many gaps are there between the soil particles. Right? Okay. So these gaps are known as what? So engineering name of these gaps are, what is the name of the engineering gap? This gap, voids. VOIDS. Okay. This void is represent the vacant place between the soil particles. Okay. And this void, this vacant space may be filled by water or air, okay, or both, right? Depending on the situation, depending on the field condition. Okay. Now, okay. So Here you can see a soil mass may contain soil solid, water, and air. Okay, that's why a soil a soil mass in nature is considered as a three-phase system. Three-phase system. How many phases are there? Three. That is solid phase, water, and air. Fine. Okay, but it is not mandatory that all these three should be present in soil. Okay, I'm giving you some example. Now suppose this is the ground surface. Okay, so suppose this is your ground surface. Okay, now uh, suppose uh, rain came. Okay, in during the raining season, what will happen? During the raining season, water will go inside the soil. Okay, water will penetrate into the soil. Fine. Now, if you take this much amount of soil from ground from here to here, okay, if you can see the soil, what you can see, all voids will be filled with water. Clear? Then क्या होगा? ये कौन सा वाला फेस में आ जाएगा? ये वाला फेस. Can you see? If whole voids are filled with water, only vacant space नहीं fill होगा ना water, because other space is occupied by the soil solid. Okay, and the volume of solid and weight of the solid will be remain constant. वो कहीं नहीं जाएगा. Either air or water. It, for air or water, it has only one place. That is what? Void. It can only fill in voids only. Now in rainy season, if a whole of voids are filled with water, okay, then you can say the soil is fully saturated. Now what about these three diagrams? These three diagrams are the just simple representation of natural soil mass. Okay, now in nature you can see this kind of structure, like a mixture of soil, water, air. It will be mixed like. Now for a better understanding, what we have done, we have just arranged all these three components systematically. Okay, now here we know three components are there: soil solid, water, and air. Okay, now what we have done, we have taken whole soil solid together and placed here at the bottom. Okay, now what have we done next? Except from soil solid, what left? Voids. So this whole represents voids of the present in the soil mass. Okay, so these voids in normal days may be filled with, some voids may be filled with water, some voids may be filled with air. Okay, if if this is the case, if voids are partially filled with water and as well as with air, then this kind of soil mass is known as partially saturated soil. Okay, partially saturated. Okay, now what is the difference between these two? Now here you can see whole void. Now see, void's volume will be same. Okay, volume of the void, total space will be same. It can be replaced by water, it can be replaced by air. Okay, now in rainy season, that we already discussed, that if in rainy season water will penetrate into the soil, then whole voids will be filled with water only. Now this is the diagram, a representation of that scenario. That means whole voids will be filled with water, but you can see this volume, this level is remain constant. You can see there is no change. The depth of the solid will remain same. This is why, because the volume of solid and weight of the solid remains same, cannot be changed for a particular cross section. Okay, so this, even here also, up to here there is no change or in the height. Okay, so that means there is no change in volume or weight of solid. So this is the case of rainy season. Okay, so all the voids are filled with water, and this type of soil are known as fully saturated soil. Now, can you see the difference between this partially saturated soil and fully saturated soil? It only imply what it is represent. It represents what present in the void, whether the voids are filled with water or not. If the voids are fully filled with water, then it will be known as fully saturated soil. And if the voids are not fully filled with water, partially, okay, so some air may be present in the voids, then it will be known as partially saturated. Now, saturation, this term represents the presence of water in voids. Okay, in this particular engineering term. Okay, engineering term. Fine. Now, so in dry season. Now let's take example of dry season. Okay, suppose there is no water. So what will happen? Whatever the water present in previous condition, they may be evaporated, and all the voids, vacant place, all the voids will be filled with what? Air. Since water is not there, that means it must be taken up by the air only. So in this scenario, this representation type of soil is known as dry soil. Now, from this name also you can understand what do you mean by dry. Dry means no water. That means if the soil mass contains no water in voids, that soil is known as dry. Okay. So depending on the phase diagram of soil, we can get three types of soil. What is the name of the three types of soil? First is your partially saturated soil, then fully saturated soil, and then dry soil. Okay. So can you understand till now? You can write in chat box, or I should repeat. Just quickly, just give respond in chat box. Do you understand? If you understand, just write yes, sir. Fine. Very good. I think this is a very simple thing to understand. There is no uh, tough concept here. Simple thing is there. Okay. Fine. Fine. Okay. Good. Good. So let's move further. Let's see what we have to know. Yeah. Now see same diagram that we have already discussed here, phase diagram. Okay, and I also have already discussed about this representation of phase diagram of soil. The same thing in a detail we'll discuss now. Now this diagram represents what? Schematic diagram of the three-phase system of soil. Okay. Now in a particular partially saturated soil mass, if you consider different constituents, and if you draw this schematic diagram, you will see this kind of diagram. I think you have understood till now. So at the bottom, what will get? Soil solid particle. Then above the soil solid, will get water, and above this, will get air. So this is a representation of three-phase diagram in a in terms of schematic diagram. Okay, fine. So we can identify some property of soil based on schematic diagram. Okay, we can identify or we can derive some definition based on weight and based on volume of different constituents of a particular soil mass. Now, before that, let's introduce to you some symbols. Okay. Now, here you can see in this left side, you can see weight symbol. Okay. Now, here in the right side, you can see the volume symbol. Okay. That means you can. I'm just representing weight and volume of different constituent uh, of soil. Okay, so say this. Okay, I'll start from the volume first. Okay, I'll start from the volume. Now if you represent all these constituent in terms of volume, now see this capital V. I'll just, wait, yeah. So now you can see I can see this V, capital V represents what? Total volume of soil. Okay, capital V represents total volume of soil. Fine. Now, since we have separated all these constituents, so we can find out individual volume of soil. Okay, so Vs, capital V with small s or capital S at a suffix, you can see this represents volume of solid. S for solid. Okay, Vs represents volume of solid, and here you can see VV, volume of voids. From here to here, this total volume represents volume of voids. This volume of voids may be divided into two parts, that is volume of air and volume of water. Okay, so we can say VW plus VA is equal VV. Okay, fine. So this is a volume representation. Now let's go to this weight representation. Now we'll start from the solid part. Okay, now see WS, capital W with suffix S. So WS represents weight of the solid. Okay, capital W with small w, what it represents? It represents weight of the water. Okay, now W small a, WA represents weight of air. Okay, now in this case, uh, this weight of air is very negligible, so we can neglect that. Okay, WA is not considered here. So if it is not considered, and if you want to find out what is the total weight of the soil mass, what will be the total weight of the soil mass, which is represented by capital W, will be summation of weight of the solid and weight of water. Okay, not which weight of air. Fine, is it clear? Since WA is small and can be neglected. But in this volume case, what will happen? Total V, total volume. Okay, total volume will be what? It's a summation of volume of solid plus volume of water plus volume of air. Okay, but in terms of, if you say in terms of weight, so total weight will be summation of weight of solid and weight of water. Okay, so this is the basic thing that you have to understand. Fine, is it clear till now? Okay, let's see what we have next. Yeah, relation in terms of volume and weight. So basically, we'll discuss this thing in detail coming classes. So till now, I'm just want to give you an overview. So I have already discussed that based on weight symbol, based on weight symbol and based on volume symbol, we can find, or we can derive some relation. Okay, we can derive some relation or interrelation. You can say we can derive some relation and interrelation of a particular soil mass. What are the relation? Like void ratio, porosity, okay, then degree of saturation, yeah, void ratio, porosity, then degree of saturation, air content, and percentage of air point. Okay, fine. So, yeah. So let's discuss little bit about this. So, what do you mean by this void ratio? Void ratio, you can see here. What is it? Here you can see the void ratio. It is the ratio of the volume of void to the volume of soil solid. Okay. So before that, I just want to tell you that first of all, we'll discuss about volume relation only. That means, okay, So we'll discuss about only we are discussing about the relation only based on volume, not with depend on weight. Okay. So whatever I'm going to discuss now, it is only depend on the volume. Okay. Now see here, volume. What is under volume relation? First relation is what? Void ratio, which is denoted by small e. Now what is small e? Void ratio. It is defined as the ratio of volume of voids to the volume of solid. Okay, and it is expressed as a decimal or fraction. And here you can see symbol. The representation is, you can see small e is equal to dB by ds. Now some time, you just remember it is the ratio of volume of voids dV divided by volume of solid ds. Now let's go back to that here. From this diagram also you can find out that same void ratio. Now what do we mean by void ratio? dV by ds. Now where is dV? This is dV. dV means what? Volume of voids. Yeah. So what is void ratio? If you find out void ratio denoted by small e is equal to this volume of voids divided by volume of solid. Okay. Dividing this volume by this volume, you will get void ratio. That is small e. Fine. So can you see dB by d? Okay. So next, porosity. Porosity is also a kind of a relation based on volume soil mass denoted by small m. Okay. So it is the ratio of volume of void to the total volume of soil. Okay. It is the ratio of volume of voids to the total volume of soil. It is expressed as a percentage. And mathematical representation is this one. Small n is equal dV by dV divided by V, capital V multiplied by 100. Since it is represented in terms of percent. Okay. So let's go back in the diagram. Let's see how it can be found out. Porosity is just mind it here dV by total V. Now you can see the difference here. Void ratio and porosity. You can see the difference. dV by Vs, dV by capital V. Okay. So in this void ratio, volume of void is divided by volume of solid, but in this porosity, volume of void is divided by total volume. Okay. Now let's go back to here. Yeah, yeah. So if you want to find out porosity, which is denoted by small n, okay, porosity is what? It is defined as a ratio of volume of voids divided by what? It is capital V. That is total volume. So if we divide this volume of void, divided by total volume of soil, that is capital V, multiplied by 100, you will get what? Porosity. Okay. So it's very small difference here. Void ratio, small e is the ratio of dV by Vs, and porosity, it is the ratio of dV by capital. Okay. I think you have got this idea about this basics idea about this phase diagram and these two parameters. Okay. So in next class we'll discuss about these three also. Fine. So here I want to stop my class. I'm just closing my screen. Okay. Before that, do we have any doubt till now? If you have any doubt till now, you can ask me. I can repeat because we have some time. I have some time so that we can discuss about that what we discussed till now. Do you understand?
Sir,
Yes.
Sir, I have a doubt. Like,
Yeah,
sir, the volume of the void is actually the total volume of the air and water, right?
yeah.
Okay.
Okay, now
We
oh,
count the void as the volume of the water and the air.
pardon again. Can you say?
Vo- volume of the void, sir.
Yeah,
The one which you told, na.
yeah,
The
yeah.
volume of the void is considered as the sum of the volume of the air and volume of the water.
Yes, yes. You can see. Can you see the sky?
Yeah,
Yeah.
yeah, yeah,
Now,
sir.
now,
I can
okay,
see.
that's great. So here you can see a soil mass contain mainly two volume. Okay. Again, I'm just telling. One is your solid part. Next is your void. Okay. So you can first divide these two volume. Okay. In mind, we have two volume. One is solid part. Next is void. Okay. Now voids is again divided, maybe divided, not always, maybe divided into two component. Like it may contain, if it contain air and water both, then volume of voids may be summation of, a second. Okay. So volume of voids may be summation of what? Volume of air plus volume of water. If, because this is a case of partially saturated soil. Okay. Now suppose this is a fully saturated soil, then what will happen? If it is a fully saturated soil, then what will happen? The whole void will be filled with water. Okay. Then what will happen? Total volume of void will be equal to the volume of water, because there is no space for air. Fine. Now suppose for dry soil, if this is a case of dry soil, that in that case whole void will be filled with air only. There is no space for water. Then in that case volume of void will be, can be said it is equal to volume of air. Okay. So volume of void, what will be the, it will be equal to volume of air or volume of water or summation of volume of air or volume of water. It depends on what type of soil it is, whether it is dry soil, whether it is fully saturated soil or partially saturated. Now can you understand? Is it clear now? You can just text no? Okay, is it clear to you? Everyone please respond here. Is it clear to you till now? Okay, great. So I'll do one thing now. For wait for some time. I'll just take a snap of your attendance. Okay. And if you have any doubt, you can just ask me now. Okay. I'll just stop my recording for that.